the test hard, but only thing is that when I start to set the questions, sometimes I run out of options. So I need to recall back what I was discussing in the class. So let's put that thing up. So hopefully students will be able to relate and understand. I don't know whether they can see from here. And what can I do? Okay, so before we start this tutorial, we are at 9:15 here. So before we start the conjugate acid and base, can anyone tell me what is the definition of conjugate acid and conjugate base? Anyone? Online friends as well. Can you tell us what is the, we can hear you if you talk. So what is the definition of conjugate acid and conjugate base? And I know it's too easy question, I think, right? So another thing is, when there is a conjugate acid, there must be a conjugate base as well, right? So both of the things coming together. Now, conjugate acid is from the base. When it lost its basicity or alkalinity, the rest ion is the conjugate acid, and the vice versa is true for conjugate acid as well. So for nitric acid, if we ask what is the conjugate acid for this nitric acid, I know it's easy conjugate base, find out the conjugate from the nitric acid, right? But if I ask you to find out the conjugate acid for this nitric acid, we don't talk about the simple thing, right? So if there were a conjugate acid for nitric acid, what would it be? What would it be? Let me write it in red. Conjugate acid of HNO3. It should be H2NO3, isn't it? But in practice, in real life, there is no such molecule. Okay, so why are we considering the conjugate base for this? So this is an acid, ammonium. Is it an acid? Yes or no? No? No. Yes, actually, and no, both. Why yes and no? Because when we are talking about the conjugate acid or base, specifically acid and base, regardless, right? Then we are assuming it is through some definition. And Bronsted-Lowry says that whatever is giving us proton is an acid. So ammonium ion, it is in nature, they cannot stay in this form. They should be conjugate with some kind of anion, right? Either chloride or fluoride or hydroxyl ion or sulfate or whatever. There should be some negative ion, I mean, let's say X should be there in practice, in nature, right? This should be the case. But since by definition of Bronsted and Lowry, if it dissociates, it is able to give us one hydrogen ion. And of course, that X, whatever was there, should be released as well, or liberated as well. So by this definition, it is an acid. So the conjugate base will be the same thing that we know so well. This is ammonia. This is the conjugate base. So this is the conjugate base of this acid. All right. So when I'm saying that, does it feel complicated? I'm trying to tell the story behind where it is coming from. Okay. So, all right. Okay. So this is sulfate, bisulfate ion. Right. Bisulfate ion. It is easy to make conjugate acid and base both from here. You just remove one hydrogen, it will be conjugate base for this acid. So in this stage, it is an acid. In this stage, because theoretically it can give us a hydrogen ion. Theoretically, right? In practice, it is difficult, but it can. So sulfate ion is the conjugate. Then okay. So sulfate ion will be the conjugate base for bisulfate ion. Is it correct? Is this the way that I write is correct? No, right? Because I remove one hydrogen, so the balance, the charge balance has to be equalized now. So hydrogen is positive here, and if I remove one hydrogen, right? So sometimes we shouldn't, we should notice this type of changes or this type of details sometimes. So sulfate ion is always too positive, right? Because why? I remember now. Because why? Do we remember the Lewis structure of sulfate ion? Lewis structure of sulfate ion. There are 4 oxygen all around it, and there are 2 charges. It is always shifting, right? Sulfate ion. Sulfate ion. This is the sulfate ion, and there are supposed to be 2 double bond and 2 single bond, and there's 2 charges on the either side of the oxygen. But these 2, okay, let's talk about this Lewis structure once again. If you have any question, you can ask. So the thing is, this oxygen and this oxygen, what is the difference between them? They're the same element. We are taking from the same element. We cannot differentiate. This oxygen is better than that one, or this is weaker than that one. We cannot tell that. All are oxygen atoms. So when they are enjoying these 2 bonds and becoming 0 charge, formal charge, why wouldn't they? They also will deserve the same thing. They are the same oxygen. So that is why, this is the literature, but the science behind this is the charge is being shifting. This oxygen, double bond will shift here. So this charge will shift there in that way. It will shift. So once this moment, the negative charge is here, the next moment, the negative charge goes to there. And so goes same way. It will shift as well. It will shift as well. That way it will shift. So can it be like one negative charge here, another negative charge here? No, it cannot be. Any question from the online student, those who are looking? I don't know how's any better way to show you. Can you see what I'm doing here? I hope that you can see. Okay, so my question is, is it possible to have negative charge on the adjacent atoms to negative charge? What does negative charge mean? What does the negative charge mean actually? It is becoming negative for what? What is the cause for this negative charge? Electron, right? Why you're thinking too much? It's a simple thing. So, it has extra electron. So that is why it is negative charge. So now, I have something for you. I have quite a few things for you to actually forgot. I got it from the airport. Please pass it on. And this is the thing that the molecule structure, I got it. Sulfur, yeah. Sulfur should be yellow color. Oxygen should we put white, blue, green, nitrogen. Oxygen is a bit bigger. red is hydrogen, so okay, let's keep red for us. Here. But another problem is there is no way that I can put two double bonds. So instead, oh, with what? Two bonds only. Do not have any yellow color for problem is it will look more like CH4, but I don't have, I mean, I see that there is no other possibility as and there is no way that I can show double bond here. Anyway, so this is, let's say, later I will show when I go for organic class, I'll show this structure again. Finish it, or you put it here. So I'll put, I mean, this is actually, it will look like carbon, hydrogen, CH4. But for this case, let's assume that the middle one is sulfur, the black one is sulfur, and there are two double bonds here and there, right? So you see that it will, they didn't give me any sulfur. It is so difficult to show from here this way. Anyway, so should I show you this way? It will probably pollute your understanding then, because there is no sulfur. Sulfur will be a bit different. Their angles will be a bit different, right? So if there is a one double bond here, the double bond is another one here. So in this case, the double bond distance is all same. It doesn't matter. It goes to here or here or here. It's always same. It will be. So that's what I'm saying, that it is not the perfect representation. This yellow was supposed to be sulfur, but they have given only two holes in this yellow. Okay, so forget about it. Now, I was telling that there are two electrons. Negative charge means two electrons. So if there is electrons at the adjacent carbon, adjacent oxygen, right? What is the problem? Two electrons. Here is one. Here is one electron. Here is another electron, number two. And these two are, let's say it is not, if not 90 degree, 105 degrees, at least, distance. But if the electron was here, they would be 180 degrees far apart. And then the more the electrons are adjacent because of their negative charge, they will repel to each other, right? If they repel each other, what will happen is there will be tension in this molecule. The molecule itself, without having any external influence, they will be tensed. So they will try to explode, implode, or whatever you say. And that is why, this is the reason that if it shifts here, the charge must shift there. The charge is shifting, also the double bond is shifting. So this is the sulfate ion structure. Okay, and that is why there are two bonds, two negative ions on the sulfate ion, right? Same thing goes for phosphate, PO4. Do you know? PO4. Is there any PO4 here? No. PO4. How many negative charges on it?
1, 3.
3. Good. 3 negative charges. Because phosphorus is coming from phosphorus. Just remember, it's coming from phosphoric acid, H3PO4. So this one, when this 3 hydrogen is going up, there should be negative 3 charges on phosphate ion. And if we try to do the same way, the charges, this way, if we try to do the same way, this charge, and just imagine this phosphorus is here, right? Phosphorus is here, all around 4 oxygen, and then there are 3 charges. You try at home and see, and tell me tomorrow, which one, phosphate or sulfate, which one is more stable and why? Phosphate ion or sulfate ion? Try at home at least. Whatever I said, you can find the answer from that explanation, but you need to try. So tell me tomorrow. Okay, so this is, come back to our adjacent acid and base, conjugate acid and base. So this is sulfate, and this is the conjugate base. And from this sulfate, we are getting another one. We are getting another one, sulfuric acid. So bisulfate ion, the same thing, is the conjugate base, bisulfate ion, right? This is the conjugate base. So from sulfuric acid, bisulfate, and then bisulfate to sulfate. From sulfuric acid to bisulfate ion is very fast. It's very fast. It dissociates very fast, and that is why sulfuric acid can, we know that it can donate 2 protons, right? But in practice, to remove 1 more proton is very hard from it, because 1 negative charge is good, it's still bearable. 2 negative charges is almost unbearable for something to carry on. What is this? HC2H3O2. If I write in this way, probably you will know, right? Acetic acid or ethanoic acid, right? So this is ethanoic acid. If the conjugate base, hydrogen ion goes away from here, so this will be the conjugate base. This is the conjugate base for it, right? Conjugate base is occurring after it has liberated the hydrogen ion, right? That is when it becomes the conjugate base. The same goes for this way. Same goes this way, like anybody has any question there? I cannot check back all the time. Please unmute yourself and talk. Okay, so this one, conjugate acid. Now, what will be the conjugate acid? It is a base. What will occur to it that it becomes an acid? Sorry? Yeah. Yes. So after it receives a hydrogen, then it will be able to deliver that hydrogen, right? So conjugate acid for this is water, H2O, because you just add another hydrogen, then only it is able to deliver 1 hydrogen from here. Now I ask you that, okay, this is, what is this? Hydroxyl, right? Hydroxyl ion. What is the conjugate base for this? Conjugate base. O2 negative. O2 negative is the conjugate base for hydroxyl ion, right? It is theoretically possible because there is a hydrogen. We are asking the hydrogen to leave, and then but you know how hard it is, right? So this Bronsted and Lowry, it is only defining that, okay, This is this, so it probably will be a base. This is probably is going to be an acid. But in practice, it does not tell us whether it will happen. So in practice, the most important, useful, not important, both are important, Bronsted Lowry, everything is important. But the most practical thing is to consider is Lewis acid and base, that the electron is being transferring from one to another one, right? So, yeah. This is a very simple thing actually. Okay, ammonia. So what is the conjugate base for this? Ammonia. Conjugate acid for this ammonia. NH4. Just now we saw, right? NH4, ammonium ion. Hydrogen bisulfide ion, bisulfide ion. Bisulfide ion is hydrogen sulfide, H2S, and is sulfuric acid and methylamine. So from methylamine, it will be dimethylamine, methylene amine, CH4NH2 plus. It will go. Okay, so using this question, any question here? Any question here from these online students? I don't think that they can see. Is it better now this way? Okay, so using the notation acid 1, base 1, and base 2, acid 2, identify the Bronsted and Lowry conjugate acid base pair for the following reaction. Here, for number 1, I will not go through all. The number 1, what is happening is bisulfide ion is reacting with, what is that? Acetic acid, good, ethanoic acid or acetic acid. It is becoming the hydrogen sulfide, right? And acetate ion, okay, or ethanoate ion. Both are okay, whatever is there for you. So in this case, who is doing what? This hydrogen, because here it becomes negative, so one hydrogen is coming here and it is taking one hydrogen, right? So by taking one hydrogen, so it is a base, right? Because it's taking a hydrogen. And it is an acid because it is giving a hydrogen. So this is a base 1. Base 1 is acid 1. And now after it has taken, it is able later on to give that hydrogen back. So this becomes an acid 1. And it can take hydrogen, not exactly from it, but from other side. So it becomes base, acid 2, base 2. So in this way, it is changing, right? Okay? Right? B, number B. B, okay. So this is, what is the name? What is the name for this HFAQ? Those are online. I also am asking you guys. What is HFAQ? What is the name for this? What is the name for this? Anything, yeah. No marks, no revoke. I mean, I won't scold you. What is that? What is the name? Okay. He doesn't know. You know. Eukaryotes. Eukaryotes. Don't need to watch. What is the name? Anything. Hydrofluoric acid. Anyone votes for it? You? No. What is the other thing that you're thinking if you don't go for here? What's the other thing you're thinking if he is not correct?
Hydrofluoride.
Hydrofluoride, hydrofluoric. That's why this is the confusion. That's why I asked the question. I hope that you will remember afterwards. Hydrofluoric acid, first one time correct, because it's aqueous medium. Hydrochloric acid, right? We know hydrochloric acid, same thing. This fluorine is just after, chlorine is just after fluorine. So if we can call hydrochloric acid, why cannot you call hydrofluoric acid? Same thing, hydrofluoric acid. Okay? When it is in aqueous medium. Aqueous medium. But if it was gas, HF gas, or anything not written anything, then hydrogen fluoride gas or hydrogen chloride gas, right? The nomenclature we have seen the first lecture, I think. So yeah, so this is the confusion, and I hope that you remember later on. So hydrofluoric, as we say, already call it hydrofluoric acid. So this is giving one hydrogen to it, and it is an acid one, and this is a base one, and it becomes a base 2, and it is hydrogen biphosphate ion becomes an acid 2, right? Easy thing. This is my habit, sorry to call it easy thing. I understand that sometimes it's not easy maybe. So if you have any question, please raise your hand. This is the best time. In the exam, if you say that I don't understand, I'm not going to answer you. Okay, this is the best time for you to ask that question. If you cannot understand what I'm saying, if you didn't hear, sometimes you're absent-minded, still you can ask. No problem. I'm happy to go over it. No problem. But I want you to make it correct in the exam. Don't ask me during the exam, what is this? I cannot tell you, sorry. Okay, so now it is your turn to tell me for D, which one is acid, which one is base? Which one is acid? You tell me, I write. Acid, base, or acid, base, which one? Base. Okay, B1, so it should be acid 1, all right? Correct? Everyone? All right, so now let's go through the logic. Why do you call it a base? Why do you call it a base? I mean, tell what you believe or what you think. Huh? Received hydrogen. Yeah, it was a neutral charge, but it becomes a positive charge by taking one hydrogen, and this hydrogen came from here, so it is a base. It received a hydrogen. Okay, good. So now I hope that you have the understanding. Auto-ionization, I think we are entering to the problem. So, the ionic product of water has a symbol of Kw. Is the equilibrium constant expression result of auto-ionization of water is shown in the following equation. Okay, so this is the equation for the water that auto-ionizes in this natural stage, and this is the enthalpy of the reaction. So this is endothermic or exothermic? Are you taking thermodynamics? No, you're taking thermodynamics, right? Second year? You too? Okay. So this is endothermic reaction. So since many of us don't, endothermic, that means we need to provide heat. We need to provide heat for this reaction to occur. And question number A is write an expression for the ionic product of water, Kw. So Kw is so easy. Okay, so for Kw it will be the Kw is the product of the ions that it produces, H3O plus times OH. Is it correct? Is it correct or not? Yes or no? Is it correct? Kw. Water ionization constant. Kw, right? And this is the product of the ions that is being produced from the ionization of water. Right? Why don't we divide by water? Why don't we divide by water? Why don't we divide by water? The concentration of, oh, when is in third bracket, it means the concentration, right? You all know. Okay, so why don't we divide by the concentration of water as well? Because we are taking it here, we're taking these things, but why don't we take this one as well? Any answer for this? Do you have? Do you know, or did you know? You forgotten maybe? Is it? How much do you, what is the Kw value at 25 degrees? Kw value at 25 degrees. 10 power? Negative 14, yes. 1 times 10 negative 14. Can you imagine how small this number is? 14 zeros after 10. This one time. So it tells us how small the ionization of water. How small the ionization of water. So if we would consider this one as well, you can, no problem. But let's say that we started 100 mole per liter, 100 mole, molar concentration. 100 molar concentration, 100 molar concentration minus 1 times 10 negative, negative 14. Does it make any difference? It doesn't make any difference. So we consider that water is not, it is not changing any concentration. It is insignificant changes in its concentration. And that is why we do not consider the concentration of water as it is. Now, okay, so this is the ionization constant. Oh, it is given here already, yes. So the change, if there is any, to the following when the temperature of water is increased to 50 degrees centigrade. If we increase the temperature to 50 degrees centigrade, whether it will be favored to do the ionization or it will not be favored. What do you think? Favored? Why it is so? Yes, good. It's a perfect answer. So this is an endothermic reaction. So when there is an increase in temperature, it will favor the reaction to proceed further. And what is l'heure? Actually, is French. So l'heure Chardley's, something like that. In a way we pronounce it. What is l'heure Chardley's principle? What is l'heure Chardley's principle? What is that? What is the exact statement? No, not exact statement. You just need to tell me what it is about. L'heure Chardley's principle. Everybody has learned it. Yeah. Yes, it is. It is regarding the equilibrium. What is it called? What? Yeah, equilibrium constant. Yes. Yeah, not concentration. Equilibrium constant. It is regarding the equilibrium constant. So, what is that? Can anybody tell me what is? Can hear. Okay, they don't have any question. They just said yes, they can hear. So, L'Heure-Chardley's principle. Okay, Baron, Ainin, Lai Yun Xiu. Who else is there? 3 of them. Ramat, you left already. Okay, so what is the large shortlist principle? I think we discussed about it last class. Equilibrium, large shortlist principle. If any reaction has attained an equilibrium, right? It has attained an equilibrium, and it is a both-way reaction, right? If I say that it has attained an equilibrium, do I need to mention it's a both-way reaction? If there is no both-way reaction, there is no equilibrium. It is not going to get an equilibrium. HCl plus sodium hydroxide is not going to get an equilibrium ever in the life. It is one-way reaction, right? It's one-way reaction. So for equilibrium, the first condition that it should be a both-way reaction, forward and backward reaction. Okay. So the shortly says that if a reaction has attained an equilibrium, right, and it is depending on many other factors to reach the equilibrium, its concentration, its time, the pressure, temperature, many things, right? It's depending. So if it has attained an equilibrium, but suddenly somebody came here and disturbed their condition. Condition means temperature or pressure or concentration, anything. It's the change. The system or the equation will move towards in a side. It will move towards a side where it can fix or it can attain an equilibrium further based on the new condition. So this is quite simple thing, right? So this is also true for our life as well. Like you're sitting on the chair and then the chair is moving. So what you will do? You will fix it in a position that maybe it is not the original position. You will move a bit and make yourself comfortable. So that's the same thing is happening. Okay, so learn short this principle, it says. And now, and based on this principle, and it says that the temperature has increased to 50 degrees from 25 degrees centigrade, Kw value will increase or decrease or no change. Kw value, will it increase or decrease or no change? At 25 degrees centigrade, we have this amount of hydronium ion and hydroxyl ion, and this equation is endothermic reaction, so that the more heat you put, the more reaction will go further. If reaction goes to this side, so this concentration will increase more, right? Concentration increases more, and if it increases more, hydrogen ion concentration increases. So if hydrogen ion concentration increases, same goes for hydroxyl ion concentration, and that is why they are more than 1.5. 10 power negative 14. It is increasing for 1 negative 14. Okay. Percentage of ionization, of course, we understand the percentage of ionization is increasing as well. Just now I said that ionization is increasing, so percentage ionization is increasing. So pH will be less, more, same, or what? pH will of course go down because hydrogen ion is increasing, right? The more the concentration of hydrogen ion, the less the pH. So when pH is 1, the pH meter, that means there are more hydrogen ion in the solution, right? And pH is 10 or 12, that means very less hydrogen ion, more hydroxyl ion in the solution, right or no? So pH of the water will increase or decrease or no change. it will decrease, right? It will decrease. The pH of the solution will decrease, but the neutrality, the water is still neutral. Although it has less hydrogen ion, more hydrogen ion in the solution, water is still, that is something, water is still neutral because they have still same amount of hydrogen and hydroxyl ion, right? But the machine does not know what is this. It just calculates based on the evidence it has. The evidence is more hydrogen ion in the solution. Okay. Question says that water undergoes autoionization as shown in the following equation. Of course, 25 degrees. The value of Kw is approximately 1 times 10 to the 14th. At 10 degrees centigrade, the value of K is approximately 2.9 times 10 to the 15th, right? If the pH of water is 25 degrees 7, what is the pOH at 10 degrees centigrade? Quite many information. Do we need all this? Sometimes you will be given too many information that you don't need. Okay, so you also need to know or need to find out what is the information that you will need. This is also a kind of test. So here, the question is asking, show what? Show your working. Show your working, that means you have to do the working. So for this case, it says that water ionization, and at 25 degrees it is approximately 10 to the 14th, and at 10 degrees 10 to the 15th, and the pH 25 degrees is 7. What is the pOH of water at 10 degrees centigrade? pH of water 25 degrees is 7, but it is asking me pOH at 10. So this information until this point is not exactly necessary for doing this part, because I already have this thing. At 10 degrees centigrade, the K approximately is this, right? At 10 degree, if the Kw is approximately 2.9, so how can I find the hydrogen ion or hydroxyl ion concentration? We remember that Kw is hydrogen ion concentration for simple equation. I'm not writing hydronium ion and hydroxyl ion, right? This is. So at any temperature, if the water is nearly not mixed, the water is not contaminated, doesn't have anything else. So at any temperature, it will have exact amount of hydrogen and hydroxyl ion, right? Exact amount of hydrogen and hydroxyl ion. So consider that we have hydroxyl ion same amount as hydrogen ion. So in this way, it will become squared, right? At that case, it will become squared. So Kw becomes the hydroxyl ion concentration. We can also say that hydrogen ion concentration is squared. Yeah, both are true. Okay. Kw can be hydrogen ion concentration squared. Both are true. But I need hydroxyl ion concentration. That's why I'm asking for going for hydroxyl ion concentration. Right. So in this case, if we just want to know hydroxyl ion, so it will be root over of Kw, and then it is, I do not have the calculator with me, but if you have, you can find out 2.9 times 10 negative 14th, 15th. All right, 10 negative 15th. So from here, we will find the concentration of hydroxyl ion, right? Concentration of hydroxyl ion, and the concentration of hydroxyl ion will be concentration of hydroxyl ion. Yeah, 5.38 times 10 negative 8. 5.38 times 10 negative 8. So this is the hydroxyl concentration, hydroxyl ion concentration. And then the POH, how can I find the POH from here? Negative log of this value, right? So negative log of, it's not third bracket, it's just 5.3 times 10 negative 8. So this is how I will find the POH of the solution. And it is giving us 7.27. So this is the POH of the solution at 25 degrees centigrade. And when we are asking that show your working, you need to show it on the paper step by step. Don't jump. Okay? Don't jump. Show it step by step. Question B is saying, consider the value of Kw. Consider the value of Kw at 10 degrees centigrade and state whether there was self-ionization of water is an endothermic or exothermic process. Give a reason to support your answer. So, you've seen already, we have discussed about it. The water dissociates the ionization endothermic process. And we see that the pH is going up, right? pH is going. Okay, so if there is a POH, what is the pH of the solution? Exactly. So pH is PO 14 minus or plus POH is equal to 14. So if we know the POH, we can find the pH is 14 minus 7.27, which is 6.63, is it? 73, yeah, 6.73. So this is the pH of the water. And we know that at 10 degrees, the water is getting less, dissociated than supposed to be in 5 degrees, in 100 degrees or anything. So that is why it is said that it is endothermic process, right? Question number 6 says that water undergoes autoionization at some following equation at 50 degrees. The ion product is this one. Expression, give the expression Kw is already given. I'm not going to do that. And calculate the hydrogen ion and pH of pure water at 50 degrees centigrade. Explain why pure water at 50 is still neutral even though if pH is not 7. So can anybody help me out to solve this problem? How can I solve this problem? It says that at 50 degrees centigrade, ion product of water Kw has a value of 5.8 times 10 to the 14th, right? How can I find the pH of this solution at 50 degrees centigrade? How can I find? What are the steps? Okay, I write it. Step 1. Step 1. Give me, tell me. Step 1. And step 2. Tell me, can anybody, what is the step 1 that we should do? to find out the problem. Yeah? Step 1. Yes. Good. So once again, same thing I said that I will not do, but I'm still doing. Hydrogen ion plus hydroxyl ion, right? Kw is, and we need hydrogen ion only, so we consider that hydrogen ion is squared, means because at any temperature water dissociate, it will have the same amount of hydrogen and hydroxyl ion, right? So step 2 is Kw is square root of hydrogen ion is equal to hydrogen ion. So from there, it is what is square root of 5.48 times 10 negative 14. 48 10 negative 14. Right? So this is the hydrogen ion concentration. This is your hydrogen ion concentration. 2.34
times 10 power of
2.34. 2.34 times 10 negative 7. So this is the hydrogen ion concentration of water at 50 degrees centigrade. And take the negative log of this value.
6.
So negative log of this. Of course, log base 10, yeah? So 2 point, this value, put it here, 6.63. So it is much acidic than it is in 25 degrees centigrade. Is it? So we stop drinking hot coffee or tea or anything. Do we? Just drink cold water. No, because water, when it goes to 50 degrees centigrade, still has the same amount of hydrogen hydroxyl ion. So it is neutralizing the thing, right? So this is the beauty of water actually. It is so mysterious thing that oftentimes we do not, and it is so abundant thing that oftentimes we do not look at it. But it has so many characteristics, the water characteristics. We'll see later on. If this type of question I'm not going to solve. Strong acid and bases. Okay, so there is a charge for a strong acid and base. Their strength is based on their ability to dissociate or give the ions, right? Hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, chloric acid, perchloric acid, sulfuric acid. This is not in the actual order. Which one is what? But why the hydro, in between these three, which one is more strong between these three? Here. So can you tell me the order of their strength, increasing order? Which one is number 1? Highest strength, strongest among these three? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry? This one?
Yeah.
So this is strong.
Yeah.
And then the next one? Sorry? This one?
Yeah.
Okay, 2, and then obviously this is 3. Anybody agree or differ with this ranking? Agree. 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 Everybody agrees? So this is the strongest or most strong acid. right? Strong means, sorry, I forgot, should ask, what is the, I mean, what is your strong mean actually? What do you mean by strong? Or what do you understand about strong? Ionizing water, yeah, good. Yeah, so hydrogen ion is strong because it ionizes in the water, and our concept of strength of acid based on that. But exactly it will be opposite. This is 1, this is 2, this is 3. Exactly opposite. If we consider that hydrogen ionization is the characteristic for it of the strength, then it should be exact opposite. So can you tell me, or any idea why it is like that? I'm telling you the answer, but what could be the reason behind it? Let me see how many we have. Otherwise, how will be? Strong acid and base. Strong acid and base. Okay, okay. Cannot talk. This is the same question I had in the Menti question, Menti quiz. Many of you corrected it. So it was by chance or what? Hydroiodic acid. This is the hydrogen, right? Let's say we draw 3 hydrogen for 3 acid. This is for hydrochloric acid, okay? This is chlorine, HCl. This is bromine, Br, hydrogen bromide. And this is iodide. So now do you understand why hydrogen iodide is more stronger? Because their bonding, it is from here, they are close bond, right? This is much longer. This is even longer bond. They are bonding, the bond distance, bond length. So it is easier for hydrogen to break up from here because it has less control. I mean, iodine has less control over hydrogen. Okay, so this is, and also for fluorine, as I mean, what is that called? That chloric, perchloric, and hypochloric acid. It's the same thing. There has a resonance. Next class tomorrow probably. We have the class right tomorrow. If I have time, I will discuss why they have resonance and why. Interesting thing, very interesting thing. Okay, so now this is our strong acid. We see, and it is not in order. Now you know already that it's not in order, right? So selenic acid, barbomic acid, these are, I mean, strong but not that strong, like hydrogen iodide. Now, it says that determine the concentration of hydronium ion or hydrogen ion and hydroxyl ion in the following solutions of strong acid and base in the water. Calculate the pH of the solution. HCl and sodium hydroxide are dissolved in the water in the solution. Oh, okay. So we have to find the pH for this solution of HCl, this solution for sodium hydroxide, this solution for calcium hydroxide. 2.5 10 times 10 negative third molar HCl is strong acid, right? I'm not saying it's strongest, but it is strong acid. So since it's strong acid, what will happen is all of it will be dissociated, right? So how many, what is the molarity or concentration of hydronium ion will be produced? Exactly, same amount. 100% it is going to be dissociated. So 2.5 times 10 negative third molar molar of concentration. And hydroxyl ion, same amount. Because if the hydrogen, HCl is dissociating, hydrogen is producing one, chloride is producing. So where is the hydroxyl ion going to be, right? The same amount it will be 2.5 times 10 negative third. So from there we can find what's the concentration of the pH of the solution. Is there any problem? No? Concentration of hydrogen ions, hydronium ion, and the following solutions, strong acidic bases to calculate the pH of the solution. So 0.001 molar sodium hydroxide. Sodium hydroxide is a strong base, right? So we are expecting how much of hydronium hydroxyl ion? Huh? I got you here. Sodium hydroxide is not producing hydronium ion. This is hydroxyl ion is producing, right? So it will produce 0.001 molar of hydroxyl ion, right? How much of hydronium ion is being produced? No, not zero. Not zero. Think a bit like it is not directly. How do I say that? Sodium hydroxide. It is dissociated. Sodium and hydroxyl is produced, and we are trying to find out what is the concentration of hydroxyl ion, hydronium ion, because this is in presence of water, right? In presence of water. So when sodium hydroxide is going to the water, water is being dissociated as well. Water is being dissociated as well. So water is producing hydronium ion and hydroxyl ion, right? So since sodium hydroxide is strong base, all of it is producing hydroxyl ion, we understand. Water does not dissociate that much, but still it is producing hydronium and hydroxyl ion. So in this relation, how much hydronium ion is being produced can we find? Is there any equation? Is there any other consideration that we should take? Kw value is concentration of hydronium ion plus hydroxyl ion. If we know hydroxyl ion concentration and Kw, we can find hydronium ion concentration. Can we? Yes. Right. So let's say we want to find out the hydronium ion concentration, and that will be Kw over hydroxyl ion. And it is not telling us at what temperature and what pressure and what condition. So we will consider that it is at 25 degrees centigrade. So it is 25 degrees centigrade, so Kw will be 1 times 10 negative 14. All right. And hydroxyl, of course, and hydroxyl ion concentration we already know from there. So from there we will find the concentration of hydronium ion. Is that okay? And same goes for here. I write it purposely. I wanted to see whether you. So the same way we will find hydroxyl ion concentration there. Because it is HCl is not giving you hydroxyl ion, it is giving you hydronium ion. Understand? Sodium hydroxide is giving you hydroxyl ion, but not this one. So we will find Kw is hydroxyl ion concentration over it will be KW hydronium ion concentration you will find is KW over hydroxyl ion, right? So this way we'll find it here. Same goes for here. That hydroxyl ion concentration we'll find KW over hydronium ion concentration, right? So this is the way we'll find it. And what about calcium hydroxide then? Who can tell me gets 2 chocolate? Yes. So this one, calcium hydroxide. Who can tell me? 7.5 times 10 power negative fifth molar of calcium hydroxide. How much of hydronium ion and hydroxyl ion I will find? I will get from here. Calcium hydroxide, yes, you are going that way. Thank you. So calcium hydroxide, let's say, it is going to be dissociated. Should I put both way arrow or one way arrow? Why? Yes. Yeah, why you're scared is that? Yes, it's a strong base. So strong acid, strong base, they do not go for equilibrium constant, they just totally dissociate. So calcium is being produced and hydroxyl ion is being produced. Sorry, what am I doing? My God. So 2 hydroxyl ions will produce.
Yes.
Yeah. Your yes is half of the answer. What is that half? Other half. Jonathan, Iman. Oh, is there one? Chem. That's right. Yesterday you were content that. Where was that?
Yes.
Okay. Good. So what is the rest of the answer? Half already as you said. So 7.5 times 10^85 molar of calcium hydroxide will produce double the amount, right, of this value concentration. So 2 times 7.5 10 the time is times 10^85. 7.5 times 10^85 times 2. This is the concentration of hydroxyl ion we will get, right? And hydronium ion concentration will be just as we have found it, right? Okay. So, any question from the online friends? Varon, Ayunshu, I mean, no. Okay, go for question number 8. There, I mean, this is quite similar pattern, so I will not do all those.
Can I have a question?
Yeah, sure.
Just now, the hydronium ion, right?
Yeah.
To find it, is it just a hydroxide in hydroxyl ion square over hydroxyl ion concentration?
Hydroxyl ion over hydroxyl ion?
No, hydroxyl ion square over hydroxyl ion. To find the hydronium concentration of hydronium ion.
Which one? Last one.
Yeah, the last.
Calcium hydroxide, yeah.
Yeah.
Calcium hydroxide. This is the one you're talking, right?
Yeah.
So yeah, okay. We find that calcium hydroxide, because it will dissociate 1:2 reaction. 1:2, right? One calcium will produce 2 hydroxyl ions. One calcium will produce 2 hydroxyl ions. So calcium 2 plus hydroxyl ion 2 negative. So if there is 1 mole, it will be 2 moles hydroxyl ion. And since there is 7.5 times 10 negative fifth, so times 2. Okay. So this is the equal is hydroxyl ion concentration I got. And if I want to get the hydronium ion concentration, so since from the equation we know hydronium ion is, let's say like this, is Kw over hydroxyl ion. Yeah. So is it the question you say? Right. Okay, or still, what you are asking, that hydroxyl by hydroxyl, is it?
No, because Kw, but Kw I thought is the hydroxyl ion squared.
No, Kw is, we know the acid water dissociation constant, right?
1.
Yeah. Sorry?
1 times 10 power
Negative 14 at 25 degrees centigrade for water, pure water. And this is, remember this number, yeah, this is good thing that she brought out. 1 times 10 power negative 14th. This is the universal truth everybody knows for water dissociation constant. And most of the time, it is not mentioned in the question. Just like STP, NTP, that normal temperature pressure, is not mentioned what's the normal temperature pressure. Just like this, it will not be mentioned. So you have to know that this is Kw at normal temperature pressure, or at 25 degree is times 10 negative 14th. Okay. Okay, so question number, next question. Calculate the pH of the resulting solution. pH of the resulting solution. Okay, so for this question, A, 25 milliliter of 1 molar HCl and 25 milliliter of 0.1 molar sodium hydroxide mixed together. Right, 25 of just for one infographic, 25 and 25 together. So this is 25 and this is 25 together. We mixed. Let's say that we pour together in another. So what will be the volume for the solution? 25 plus 25 is 15, right? 50. It will be double. So it will become double. 25 milliliter, 25 milliliter, 0.1 molar, 0.1 molar of HCl, 0.1 molar of sodium hydroxide. Okay, so mix together. What is the pH of the resulting solution? So for this case, how do we understand that there will be reaction? Sodium chloride and water will produce, don't we? We know, right? So sodium hydroxide and HCl. So what is being produced? NaCl, this is a table salt, and H2O. So it's easiest reaction in chemistry. So we are producing here and we added 25 milliliter 0.1 molar, 25 0.1 molar, and water sodium chloride. So how much has been left, or how much was left over, how much was not reacted, how much has been produced? How can you find? 25 milliliter 0.1 molar. Can we find as it is? When we say that the reaction has been occurred, right? The reaction has occurred when we say. So in that way, what do we? I mean, how do we describe that? How much reaction has occurred? What is the condition for this? We need to know number of moles, because the reaction does not, in chemistry, reaction does not occur in how big is the volume, or how many kilos is there, or how heavy it was. It doesn't. How many moles? Number of moles is the most important thing in chemical reaction. So 25 milliliter of 0.1 molar HCl, how many moles are there?
1.
How do you find it?
N equals C.
N equals C times V, right? Very simple equation. And C is 0.1 molar and V is 25 milliliter. 25 milliliter. 25 milliliter, we cannot use it as it is. We must convert it to liter first. 25 milliliter, 1000, it will be liter. In that way, right? So, yeah, Ezra was telling how many, how much?
1.5 times 10 power negative
10 power negative 15?
3.
3. And this is the same thing, 2.5 times 10 negative third, right? So this is the number of moles. Look at the equation now. Look at the equation. What is the ratio of the equation? Stoichiometry. We will learn next lecture, next week hopefully. But what is the stoichiometric ratio of the reaction? 1:1. That means 1 mole will take up 1 mole, produce 1:1. Right? 1 mole of sodium hydroxide will react with 1 mole of HCl, produce 1 mole of sodium chloride and 1 mole of water. If it were like 100 moles of sodium hydroxide, it will react exactly 100 moles of sodium hydroxide, right? Exactly 100, provided that it is available. If it was not 100 milliliter, then what will happen? That whichever is less, it will finish first. Whichever not, I mean extra, it will stay there. So if it were X amount, it will exactly react with X amount. Same concept. So since we have 2.5, there is 2.5, so there is no leftover on the left side. There is no remaining on the left side. Everything goes to sodium chloride and water. So how much sodium chloride is produced? Exactly 2.5 times 10 negative third, and this is 2.5 times 10 negative third, right? Sodium chloride and water produced. But this question is asking what is the resulting pH? Sodium chloride came from sodium hydroxide and HCl. Both are strong acid and strong base. And we have already learned that those acids and bases are coming from strong acid, strong base reaction. The source are coming from strong acid, strong base reaction. They do not have affinity to go for hydrolysis. They will not dissociate the water much. All right. So that is why they are neutral. They do not have any too much effect on the water dissociation, and that is why the solution pH will be near about 7, almost 7. It will not change. All right. So pH is neutral. Now come to this question number B. Okay. take a paper and pen. Do you have paper and pen? Everybody? Yes. Try this number 2, B. Try number B and make mistake so that we can discuss. If you do not make mistake, I do not know. Those who are online, also try number B, 8B, and see how, where you need some additional information if you need. $50 milliliter, 0.1 molar HCl, 30 milliliter, 0.1 molar sodium hydroxide. First, what do you want to get? What the information do you want to extract from here? What is the information you want to extract from here? Okay. US 2.690. So, what is the first step you want to do? Exactly. And then, after that, you need to know how many moles are getting, right? If there is a negative or amount or something problem. So, how many moles are getting? Okay, so here, same thing like that problem, same thing like this problem, the reaction. So I'm using the same equation actually, just change the values on the information. N equals C into V remains the same. And here we see that 50 milliliter 0.1 molar HCl. So 50 milliliter, 0.1 molar HCl means 50 times, 50 over 1000, sorry, times 0.1 molar, number of moles. It is the number of moles for HCl, and for sodium hydroxide is 30 over 1000 times 0.1 number of moles. So what is the value? Yeah. 5 times 10 power negative 30. And this one?
3 times power 10 power negative
3. Right. So this is, now we see that since the reaction is 1:1, and I have something here to consider, there will be leftover. Right? 1:1 reaction. So here I have more, or here I have more?
HCl is more.
HCl is more. How much of the HCl will be left over? The answer will be uploaded later on. So in the answer, it is in the box. You have to do initial, final, so that way. But anyway, so how much HCl? I mean, this much will be reacted. 3 times 10 negative third moles will be reacted. And the rest, which is 2 times 10 negative third, is not reacting, is not going anywhere because it doesn't have to do anything. It is left in that space because it doesn't have anything to react with that much. So I will deduct 3 times 10 power negative third, and I will have 2 times 10 negative third, this number of moles at the end. Right? And this is HCl. So 2.2 times negative third means the same HCl, same hydrogen ion concentration. Right? Same hydrogen concentration. So pH will be negative log of this value. This is how you get, right? 2.6. Is it? There is a problem here. There is a little bit problem. I show you where it can be a mistake. So next time you cannot make the mistake. pH is the concentration, not the number of moles. pH is the concentration, not the number of moles. And when you are adding 50 milliliter plus 30 milliliter all together, right? And HCl is still there in this solution, right? This 2 times 10 negative third HCl is here, all together. And this becomes 50 times 80 milliliter solution now. So the concentration is not same. Number of moles divided by the concentration. You will find the volume. So you find the concentration, right? So 80 means how many in volume, how many liter? 80 milliliter in volume. Of course it is in volume. I mean liter, not in milliliter. 0.08. Right? So this is the concentration you find, the number 0.025. So 0.025. And the pH will be accordingly. Huh? Yes, pH is 1.6. So you know where it can be a mistake. Don't make that mistake. Those are online. I'm sorry. I mean, can I call you Lai? Veron, Ainin. You get what we are discussing, right? Don't make this type of mistake. Okay, so another question. 100 milliliter of sodium, HCl, 35 milliliters of barium hydroxide. Same way. It will go the same way. I'll just show you the reaction. HCl plus barium hydroxide. barium hydroxide, right? So it is producing what? Barium chloride. It is producing barium chloride, Cl2 plus water, and water it will produce. So you see that one barium, oh, it will be 2 as well. So 1:2 reaction. This 1:2 reaction. Similar ways, but only here the stoichiometric ratio is different. So 100 milliliter, 0.1 molar HCl is how many moles? Number of moles. 100 milliliter.
0.01.
0.01 number of moles, right? N equals C into V. Okay, 0.01. Barium hydroxide, 35 milliliter of 0.1. 0.03 times 0.1.
3.5 times 10 power negative
3.5 10 power negative third. Okay, so in this way, which one is more, HCl or barium? Which is more?
HCl is more.
Yes, 0.01 is more than negative third. Negative third is more. So one thing is, one barium is taking 2 hydrogen, I mean HCl, right? So this amount will take double of this, right? One is taking 2, so 3.5 times 10 negative third will take 7 times 10 negative third of hydrogen, I mean HCl out of this 0.1. So if we deduct that much, 7 times 10 negative third, negative 7 times 10 negative third, we deduct how much will be left. This much HCl is left in the solution, final. So this is initial, right? This is initial, this is change, and the final is the difference between them will be the final. And again, we have to consider the 35 milliliter and 100 milliliter. So altogether, the final value is, when we are going to find out the hydrogen ion concentration, it will be 135 milliliter. So we have to find out the hydrogen ion concentration this way. Okay, we have to find the hydrogen concentration by considering the hydrogen, I mean the total volume. So total volume will be 135 milliliter. And that is how we will find hydrogen ion concentration. Okay, so how many minutes we have to go? 10 minutes to go. Weak acid. So far we have seen strong acid and strong base. Now we are moving to the weak acid and weak base. Right? And the problem of the weak acid and weak base is they do not dissociate fully. Right? They do not dissociate fully. Question number 9 says, which of the following acids is stronger acid? Calculate the percentage of ionization and pH of the solution. Benzoic acid, which has a Ka of 6.46, and hydrofluoric acid, which has a Ka of 6.7 10 power negative 4. Right? So which one is the stronger among these two? Percentage of ionization and pH of the solution. How do you know which one is stronger acid? What will be the characteristic of the stronger acid? What is the characteristic of a stronger acid?
Stronger acid.
Yeah, strong acid. Yes, or in other way, we can say that percent of ionization will be higher percent of ionization. So if we can only find what is the percent of ionization once we find the percent of ionization. How do you find it? Percent of ionization, benzoic acid. So this is the benzoic acid, C6H5 CO2H, COOH actually is the benzoic acid, and it is being dissociated. Can I write it in this way? Or I should write this way.
This way.
Why?
Because it is a weak acid.
Yes, this is a weak acid, so it's partially dissociate. So C6H5COO, and then this is hydrogen ion. This is negative. So this is happening at the beginning, initial point. Initially, we have 4 times 0 times 10 negative second molar. At the very beginning, 0th moment, 0th second, the ionization hasn't started almost. So at the beginning, we had 0 concentration. But after some time, let's say after X amount of time, or no, not X, because I'll be using X here. After certain period of time, let's say a few minutes, that is the change, the X amount has been dissociated. So negative X. X has been dissociated from the original concentration or number of moles of the solution. Okay, and then if X amount has been dissociated, the same amount should be produced here. So A plus. So this sign in front of them is quite important. It's quite important. If you make a mistake in this sign, your whole calculation will be wrong. Okay, so an X amount has been produced. That's right. So this is change. And what is the final outcome from this? So the final is at equilibrium, or final, you can say. Okay, so 4.0 times 10 negative second minus X amount, and it is X, Add this table. This is the ICE table, right? This is ICE table. Okay, so okay, so how do you find what is the concentration of hydrogen ion now? This is the Ka value, and Ka is equal to Now tell me the equation first. KW. Good. You have noticed it. I would tell you anyway. You have noticed, very good. Remember this thing. Probably it will be needed. But now we will be not using this thing. There is the base dissociation constant times acid dissociation constant is equal to water dissociation constant. This is a nice and very strange relation, but still very useful. Probably you will need it, but remember. So Ka will be the hydrogen ion concentration. Hydrogen, after a long time, I'm writing on the board, and my handwriting is always bad, and it's even worse now. And also the line I'm drawing is not straight. So C6 H5COO negative, and this is hydrogen ion positive divided by exactly the same thing, C6 H5COOH. So this is the equation for dissociation constant, acid dissociation constant. Okay, and we know this is the value for acid dissociation constant. We can just plug in here, but for this case, is the exact amount, right? X and X is X and X. So this is X, this is also X. So it becomes x squared over, this is the original one, 4.0 times 10 negative 4. 4 times 10 negative second minus x, and Ka value is 46.46 times 10 negative 5. All right. So from here we can find x. If we find x, how do you find x? We assume that this one, or not this one exactly, sorry, not this one. We assume that this whole figure, this x is so small because it's weak acid, is so small that we can neglect this x and keep the same 4.0 times same thing, right? So yeah, so it will be it will be 4 times is 6.46 times 10 negative 5 times 4 times 0.10 seconds. So this is the value we will find x, right, from here. And we can find out the percent hydrolysis from here, taking the x and using the same concentration over 100%. So we will know that concentration. If it is less than 5%, then our approximation is valid. If it is more than 5%, our approximation is not valid. We have to go for the quadratic equation, which we will see next time. Okay, and yeah, so this is how we will find out what is the strongest. So another thing. Which one will be more stronger, A or B? We have to find out the same way the B, question number B, and see how many percentage, what is the percentage of ionization for B and A. Once we find X, we will find the percentage ionization, right? This X will be over 4.0 times 10 negative second times 100%. All right. We'll find the percent ionization for A. We'll do the same way B. So we'll see which one is higher percent ionization is happening. Whichever is higher is stronger acid. But looking at the Ka, can we tell which one is stronger acid? The bigger Ka means the more ionization occurring. So this is much bigger than this one. Negative 4th, this is negative 5th, is smaller even, right? So it's supposed to be hydrofluoric acid is stronger than benzoic acid. Okay. So any question anybody has? You have class now? Okay, good. Okay, so any question anybody has? Any question? Not necessarily from this. Yeah.
The hash is we can see where the
H.
hydrolysis.
Yeah, H. Yeah.
The acid, right?
Yes.
But why the corrosive is strong?
What?
The corrosive is strong.
Corrosive. It's very corrosive.
It's very corrosive.
Hydrochloric acid is quite corrosive. It scratches on the surface.
Why is corrosive like this?
Corrosivity is different than strength. Okay. Corrosive is how much it can remove the electron so that the matter is removing from the surface. Right? So corrosivity is different than strength. And for fluorine, hydrofluoric acid, the corrosivity is fluorine so electronegative. So electronegative. Whatever it gets on, it will try to get electron.
It's a strong
Highest. You will get highest. So that is it. Even HCl as well is to some extent not that corrosive, but it can scratch. Okay, so thank you very much for your attention. All the best. No question I can see. No question on the chat box or anything. Okay, so I'll see you tomorrow during the class again. Same formation. All the best.